Hi everybody, Luminary here again with another video. This time we're going to talk about electricity. Now, just off the top of your head, can you think of anything that's changed our lives within the last, say, 200 years more than electricity has? If you think about it, this has changed the way we store and prepare food. It's changed the way we spend our spare time, where, when, and how we work, how we travel, and even how we diagnose and treat injuries and illnesses. Now, for something that influences our lives so profoundly, have you ever really stopped to think, what exactly is electricity? We know that electricity happens in nature, but it wasn't until about the 1830s that we were able to actually generate electricity to use in so many ways that change our lives today. Over the years, we've gotten way better at how we use electricity and how we produce it, but we're nowhere near done with finding new ways for electricity to change our lives. To understand electricity, the first thing we have to remember that it is not a primary source of energy, it is in fact a secondary source of energy. That means we have to use primary forms like coal, gas, and nuclear power to generate electricity. And in turn, we've got to understand that we refer to electricity as an energy carrier, which means it can be converted to other forms of energy, such as mechanical energy or heat energy. Now that we've discussed all of that, we still haven't answered the fundamental question, what is electricity? The answer is really simple. Electricity is the flow of electrons. When electrons are lost from an atom, the free movement of these electrons makes an electric current. There are two kinds of electricities that we'll take a look at. The first kind is static electricity. Static electricity is a form of electricity resulting from the imbalance between positive and negative charges within a material that occurs when electrons move from one material to another. If the electron receiving material is either isolated or not a good electrical conductor, it tends to hold on to the electrons, resulting in a buildup of electric charge. Since this charge is not moving, it is referred to as static electricity. When conditions allow the built up charge to flow, the surplus static electricity is discharged. Whereas static electricity refers to a buildup of electrons on a surface, current refers to the flow of these electrons. Electrons typically flow in a circuit. A circuit is a continuous looping pathway for electrons to flow. Now, there are a couple of different types of circuits, and we'll look at both of them. The first one we'll look at is called a series circuit, and this is a circuit that allows only one pathway for current to flow. So, if you have multiple components attached to the circuit, like for example, we have the multiple light bulbs attached to the circuit that you see here, both of them have to be in working order for the circuit to allow electricity to continue flowing. This is compared to a parallel circuit, which allows multiple pathways for electricity to flow. That means if one or more of the components fail, the others will continue to work. Both parallel and series circuits can either be opened or closed. You need a closed path or a closed circuit to get electric current to flow. If there's a break anywhere in the path, you have an open circuit and current stops flowing. Now, you've heard me use the term conductor before, and for a material to make a circuit, it has to be a good conductor. We're not talking about that person that leads an orchestra, though. All we're doing is talking about a material that allows electrons to flow easily. Copper and many other metals make great conductors. The opposite of a conductor is an insulator, and just as with these thermoses, where the free flow of heat is impeded, an insulator, in the sense of an electricity, is when the free flow of electrons are impeded. This is important when making things like insulation for wires. When we handle wires, we don't get shocked because the outer covering is made of good insulating material. Finally, a semiconductor is somewhere between a conductor and an insulator. In other words, it conducts a little bit better than an insulator, but not quite as good as a conductor. Examples include things like silicon, germanium, and gallium. Semiconductors are the foundation of modern computing devices such as smartphones and laptops. They're also in routers and switches and communication devices. So, without semiconductors, things like modern computing and the internet would not be at all possible. And that brings us to the end of our first of two videos on electricity. Our second and final video on electricity will tackle Ohm's law. Thank you so much for watching, and if you've liked this video, please like, subscribe, and comment. It really helps us out. Have a great day.